Hey guys, today we're going to talk about electric forces. And electric forces, like magnets, either attract or repel. Electric forces also have a field around them, like magnetic fields, and this is an area around an electric charge that experiences the force exerted by the electrical charge. So let's break this down. Um, Electric charge is made up of protons and electrons. Electric currents look for the path of least resistance. So, lightning is an example of an electric force. And when you see lightning strike, a lot of times you'll see tiny little flashes of light break off from the lightning strike. That's because it's looking for the path of least resistance to the ground. Now, an electric current. This is an example of an electric current. So the battery pushes the electrons around a circuit to the positive side of the battery. So it goes around, and then a switch. Once this breaks in a simple circuit like this, once that switch is flipped and it's open, that electric current can't travel anymore. Thus, the light won't light up. It's stopped. Now this is static electricity, okay? If you've ever rubbed a balloon on your hair and you've made your hair stand up, this is an example of static electricity. It does not move through a current. So to explain why that happens, why the static electricity happens, when a balloon is rubbed on your hair, the electrons are removed from your hair. Remember guys, electrons are lost and gained easily, okay? So the balloons are now attracted to the positively charged hair, right? Because the balloons have all of those electrons. So that's why your hair stands up to go toward it, where the balloon is attracted to the hair. And what are some other examples of static electricity? Guys, walking across a carpet and then touching a metal door handle. You know how sometimes it'll give you that shock? Printers. These are made with static electricity. So static electric charges attract ink to the paper. And then lightning is also an example of static electricity, guys. So electromagnetism. This is when a current flowing through a wire is surrounded by a magnetic field. So you have both an electric current and a magnetic current, and that's electromagnetism. So this is an electromagnet. Now, if you wanted to make an electromagnet, guys, we would do this in class, a little activity, and make one and make them stronger, but we can't due to COVID. I'm really sorry. I wish we were in class to do this, but I'll post a video of the actual experiment. That way you can see. So to make an electromagnet, you wrap a wire around a piece of iron or steel to make the magnet stronger. And how can you increase its strength? You increase the number of loops that wire is going around. So this increases the current, or you increase the current or the voltage. Now, unlike a permanent magnet, the strength of an electromagnet is easily changed. So that's a little bit of information on that, guys. And then we're going to look at this. I made this to show you how electricity and magnetism are related effects. So we're going to start here with magnetism. Just as a review, we know that it's a force that exerts a push or pull, like poles repel, opposite poles attract. Magnets can be natural or man-made. So they're found throughout the world. Magnets produce a magnetic field. Earth acts as a giant magnet, and that's why we have the north and south poles. So Earth's magnetic field is caused by circulating electric fields that surround the molten core. Then a compass is an instrument that uses a freely moving magnetic needle to indicate direction. And the compasses all have to do with the North Pole. That's where they point. Now, electricity may be static or current. Static electricity is the buildup of electric charge. Lightning is the discharge of the static electricity. I'm doing a recording, guys. Electrically charged objects attract or repel each other. Shh. Shh. Oppositely charged objects attract each other. Like charged objects repel. All right, guys, so we're going to move on to here, where current electricity is the flow of charge and or electrons in a complete circuit. A current is a path by which charge or electrons flow in a complete circuit. There are three types of currents: simple, series, and parallel. Shh. Now, a simple circuit is a path. I drew an example over on the other page, and this is which electricity can travel. Um, a parallel circuit has multiple pathways for electricity to follow. If one bulb goes out, the other can stay lit. There are multiple pathways, okay? Kind of like how lightning, when it strikes down, it's got multiple pathways through the air. Electric energy may be transferred into heat, light, sound, and motion. So there's many uses of electricity: doorbells, lights, motors, toys, all of these things that we use electricity for, guys. This is what electric energy can be turned into. So we'll go ahead and take our our test over electromagnetism. And if you guys need any help, be sure to let me know. Bye.